afternoon, everyone, and welcome to Future Plymouth 2030. My name is Miles Noble, and I'm here to take you through the webinar this afternoon. Happy New Year. I hope you're all well and healthy and safe. We've got a great lineup for you this afternoon, so sit back and enjoy. We have four great guests. We've got Peter Kydd from Southwest Infrastructure Partnership. Peter will be talking about infrastructure and the future energy needs for our country. We also have Dr. Zaki, Ahmed and Jonny Bloor from University of Plymouth, who will be talking about power electronics. And finally, we have Alistair Macpherson from Plymouth Energy Community, who will be talking about the rationale for community-owned energy infrastructure solutions. We have a Q&A session at the end of the programme, so please stick around for that. If you would like to submit your question via message, please use the Q&A button at the bottom of the screen. But if you prefer to ask your question directly, please stick around and raise your hand by clicking the raise hand button at the bottom of the screen at the end of the programme. We also have some interactive polls throughout the programme as well, so please look out for those. So without any further ado, I'll hand you over to Peter Kydd from Southwest Infrastructure Partnership. Peter.
Hello. Right, it says unable to start video here, but I hope you can. Let me just get the screen up so hopefully everyone can see that. Let me begin. First of all, my name is Peter Kydd. Thanks, Miles, for introducing me. And before the other speakers talk about technology and innovation, I'm going to be painting a picture of what our future energy needs are going to be as we move into our brave new world of net zero. I'm going to base my talk on the net zero pathway published by the Committee on Climate Change last month in a document they called the Sixth Carbon Budget. Despite the rather boring title, it's a very, very good read. So do Google it and have a look. First of all, a little bit about me, for those who don't know me. I've have to say, it doesn't seem like 40 years, but I do have 40 years experience now in strategic consulting, focusing on water, environment, low carbon infrastructure and net zero. I'm a fellow of the ICE and I chair the Southwest Infrastructure Partnership. Please Google that as well and click on the join up page. It's free. And we try and keep you up to date with what's going on in the infrastructure world in the Southwest. So it's open to everyone. And as well as my role with SWIP, or Southwest Infrastructure Partnership, having retired from WSP, I continue to act as a consultant to them and have been pretty busy actually in the last few years. A little bit more about me. I live in Bristol, but my work has taken me all over the UK and the world, including Plymouth. Although I'm now tied to a home desk and having been helping WSP with net zero services for their clients during these COVID times. So I think it's all an experience that we know, going from our dining room to our office and the shortest commute possible. So let's start. Why do we use energy, and why is it so critical to net zero? Some questions to ask yourselves. What are our energy emissions today? What do we use energy for? What needs to change? What's happening? And what will the future look like? So I'm going to look at each of these in this short overview. First of all, energy accounts for the vast majority of emissions, as you can see from this graph. If you look at the colours in order of magnitude, got transport in purple, buildings in orange, industry, which is grey and dark green, and we've got electricity, which is yellow. And as you can see, that they account for more than 70% of all the carbon dioxide equivalent emissions. So energy is absolutely critical to achieving net zero. As you see from this graph, of these areas, only electricity and industrial emissions have reduced since 1990. Progress over the past decade in the electricity sector has been impressive, and with a significant increase in renewables and the throttling back of coal. However, that rate of change will need stepping up over the next 3 decades, as you will see. Transport and heating for buildings continue to rely heavily on fossil fuels, and there's been very little change in these emissions, as you can see from those rather flat lines. So what do we use energy for? Well, you all know this, of course, practically everything, as this slide shows. Now, some interesting facts. Whilst everyone thinks working at home is zero carbon because we're not traveling, in fact, the power used to drive the data service for our broadband are, according to a BBC report last year, responsible for up to 20% of the world's greenhouse gas emissions. So expect to see a significant investment in renewable energy by the big tech companies, and some innovation around how they dispose of their waste heat. Other interesting points: EVs are better than petrol or diesel cars, but they aren't zero carbon when you take into account the emissions that arise from their manufacture and their disposal. And how do you persuade house occupiers and owners to change to a new form of heating, given that burning gas is not compatible with our new net zero future? But as you will see, energy is required for absolutely everything we need to stay alive, including treating our water, transporting our food, and heating our homes. Now, none of this is new. This is a slide I produced and first showed back in 2012. It shows how energy output from our existing electricity generating stations drops off. That's the red line. Whereas the blue line shows the energy output we need if we're going to use electricity to decarbonise the majority of our heat and transport emissions. In other words, we need to more than double our existing output, and the increase in the number of our generating stations is going to be huge as a consequence, from around about 80 gigawatts today to more than 200 gigawatts by 2050. And because wind and solar farms have an operating life of 25 years, and 2050 is more than 25 years away, we'll have to replace these as well as build more to increase the capacity. So what needs to change? Quite a lot, as this graph shows. Progress has been made since 1990, and that's good news. But decarbonisation of the electricity sector, plus heat and transport, is a priority. The rate of change needs to increase, and we're now dealing with the more difficult challenges. Now, most of the Southwest councils have adopted climate emergencies with a target of achieving net zero by 2030. Hugely challenging, but not impossible. Although I'd not put any money on getting there by then, personally. Even 2050, the government's target, will be touch and go, and I'm going to explore the changes that we need to make in order to get there in a little bit more detail. And an important point here is that to succeed, this isn't just about what government does or what our local authorities do. It's about what action is needed by everyone. How do you do your shopping? What cars do you buy? How much you travel? What you replace your home boiler with when it expires, and so on. But it also needs change from government so that the policies and associated measures are put in place to help us make those decisions. And all of those who run businesses associated with emissions, from car and boiler servicing through to freight transport, need to do their bit as well. Now, the work being undertaken by the Climate Change Commission is extraordinary. Their latest report, published last month, demonstrated exactly what we need to do as a country. Their balanced pathway involves using everything we have in the armoury, from decarbonising the electricity grid to switching to electric vehicle fleets, deploying low carbon heating systems, and using carbon capture and storage where emissions can't be avoided. They also make the point that as one of the world's richest nations, we have a responsibility to lead. We wait to hear whether our government will accept the CCC's recommendations, so fingers crossed. Now, the Climate Change Committee compared their outputs with those that Citizens' Assembly, which met during the summer, also made their own recommendations. And rather than go through this slide in detail, let's just say that the good news is that there is a lot of overlap. So it looks like we're all heading in a good direction, which the majority agree with. So looking at the electricity grid, which is probably the most important thing or the most urgent action we need to take. National Grid produces annual projections of what will be required in electricity capacity to 2050. This is known as their future energy scenarios. Again, you can Google it and download their reports from the internet. Now, this graph is from the latest scenarios, and you'll see it looks very similar to the curve that I put up in the graph from 2012. So we've known what we need to do for a long time, or do we? Now that's the question. So I produced a little step-by-step guide to what I think we need to be achieving. Starts with step 0, and that's all about joined up thinking. Some people call it systems approach. And we need to take up a joined up approach, breaking down departmental and sector silos and working together to adopt the optimal solutions with a recognition of how decisions taken in one area can have consequences in another. And I'm not going to go through these steps in detail. The slides, I'm sure, will be made available afterwards so that you can read them in more detail. But it's really the key principle that is important, that we need to work together. We need to put solutions in place, and they need to be cost effective before we're likely to see any change. We have to make it easy for people to change. Now, step number 1, as I said, is decarbonising electricity generation by 2030. That's going to require all our low carbon electricity generation capacity, including renewables, nuclear, as well as other measures, including improved efficiency and flexible use of our energy to spread demand. And I'm sure we're going to hear a little bit more about that in the subsequent talks today. Most of this people will be familiar with in terms of electricity network, as none of this is particularly new, and the Prime Minister's 10-point plan summarised most of this as well back in November. Now, moving on to more difficult challenges. Step 2, decarbonise transport as soon as possible. It is happening, and there are some big questions, though, that also surround this, particularly regarding how do you decarbonise freight. HGVs, for example, can't really run on electricity unless you can envisage a motorway network where we've got overhead wires throughout the whole network to enable HGVs to run across it. So we have to look for different solutions for HGVs. Maybe it's hydrogen, but you need low carbon energy to manufacture the hydrogen in the first place. So actually it will be it will increase our energy demand. Other solutions are possibly repurposing the rail network to shift more goods from road onto rail, because it's much easier to electrify rail. Step number 3, and we're getting into some really challenging areas here, reducing domestic heating emissions starting now. And I'm not going to talk about new homes now, because I think it's relatively straightforward to build new net zero homes. The challenge there is to get the developers to step up to the mark and build those homes without necessarily requiring building regs to make it mandatory. It would be nice, though, if building regs did make net zero homes in the future mandatory. It certainly help things. So how are we going to reduce domestic heat emissions starting now? I mean, you know, this affects all of us because we all have, or the majority of us certainly, use gas to heat our homes. And so we're going to have to look at choices of changing our boiler and replacing it with an electric heat pump. But that's a lot more expensive, certainly in upfront costs. And to be effective, you need to possibly replace your radiators with larger ones because it's a lower grade of heat, and we need to insulate our homes, and that's a real challenge for homes that were built in the early part of the 20th century and Victorian homes and so on. There are other options. I mean, we may see hydrogen blended with natural gas as a transitional measure, for example. There's a lot happening in this space, but no clear answers have necessarily come up. The Climate Change Committee has suggested that as an interim step, all new boilers should be sold to be able to also work off hydrogen fuel as a precautionary measure. Step number 4, well, alternative energy sources and approaches. So I've mentioned hydrogen. I mean, that's the big one, but it is expensive as it requires low carbon energy to produce it in the first place. But, you know, it may be the only option we have for those difficult to electrify uses such as HGVs and industrial heat as well, for example. There's also a fundamental question we need to ask ourselves under this step, and that's how we use energy. You know, our use of energy has evolved. Do we really need, should we be going back to the drawing board and saying, right, where do we actually need to use energy? What's the right balance between essential and convenience? And how, you know, is this transition from our current system to a new system, which is going to be quite dramatic? Does that provide us with an opportunity to consider how we use energy? And it's not always easy to do the right thing. Government doesn't necessarily help us, and it's a lot of us have to make up our own solutions, as you can see from these innovative ways of charging cars when you don't have a driveway. So I think there'll be a lot of thinking that goes into how do you open up electric vehicle charging to the many, where they can use their own lower cost electricity and be able to park on the street and charge their vehicle. So if we look at the sort of national picture and what's happening and what's driving down from a policy point of view, I mean, the good news is that the government is now very much on the case. And we've seen a plethora of documents and policy changes that have been announced in the last months of 2020, as you can see from this slide. You know, we've had the Prime Minister's 10-point plan. We've had the Climate Change Commission reports, which are recommendations to government. We'll wait to see what government will say in response. They've accepted all of their previous recommendations, so hopefully they'll accept these. There's the Energy White Paper, which has got some very similar conclusions to the Climate Change Commission's reports. There's a new national infrastructure strategy, which takes all of those requirements and puts it into the context of what new infrastructure we need. And certain, you know, there are certain key issues there, such as what do we do with our gas network, and how do we extend our electric vehicle charging network. There's a forthcoming hydrogen strategy. I think that's due in the next month or 2 months or so. All of our local authorities have been producing climate emergency action plans. And the good news is that a lot of the COVID economic recovery plans have embraced those climate emergency action plans as well. So it looks like we're using this COVID pandemic reset as an opportunity to be able to build a greener future. So what will the future look like? will we see Cornwall covered as in forests, as was proposed in one of our SWIP workshops last year? I mean, that came out as a one of the strongest ideas. We've gained a lot of support, and also one of those ideas that got very little support because they thought turning Cornwall into a forest would not be a good idea. It would limit any economic activity there, and there is a lot needed in Cornwall. What about the other areas? I mean, should we be following Norway? Where every other vehicle is now an EV. I mean, they've had some tremendous success there in converting from fossil fuels to electric vehicles. And how do we convert that sort of COVID lockdown effect on the environment that we all saw last spring? How do we make it a more permanent feature in our future lives? Because I think everyone appreciated the what the environment was telling us at that time. And finally, your thoughts to look into 2030 and to ask yourselves some questions. How do you think you're going to be working in 2030? What will your home heating system look like? Will you be using the car less? How will you do your shopping? What will your town centre look like? How will you enhance your quality of life? And what will your carbon footprint be? So that was all from me. Thank you very much for listening. I think there'll be some questions afterwards, but I think Miles probably has a poll now related to this.
Yes, really interesting poll from Peter. So I set this one live. So the question is, how many times has the National Grid had to issue a notice warning of potential shortage of generation this winter? Interesting results here, Peter. So I was quite surprised, actually. So we've got 19% saying 1, 29% saying 2, 38, which is the most, at 3, and then 14% 4. So who's right?
And the 14% are right. There were 4 emergency notices issued this winter, and that's very high, very unusual.
Do you know what, kind of times they were? Was it around Christmas then?
There was one after New Year, and then there were 3 in the build-up. I mean, they're really more related to weather temperature and when everyone sort of turns up their heating and so on. Whether home working has sort of boosted the numbers this year, I don't know. But I think, as we see our electricity network become increasingly reliable or reliant on wind power and solar power, we did have a period in December where the wind didn't blow, and that I think is the main issue. So wind doesn't blow, you've got to use some backup. If the backup isn't there, because there's not a future for some of that backup, like coal and so on, then you get a bit of a squeeze on margin.
Cool. Well, thanks very much for that, Peter. It's really interesting. Thank you. We've got some questions coming in, which we'll leave to the end. Again, if you would like to ask Peter a question, please raise your hand at the end or send us a question in now by clicking the Q&A button. So next up, we have Dr. Zaki Ahmed and Jonny Bloor from Plymouth University, or the University of Plymouth, sorry, and they're going to be talking about power electronics. So over to you, Jonathan, I believe, first.
Sorry, just unmuting myself. Everyone hear me okay? Yeah. Great. Okay, lovely. Well, firstly, I'd like to welcome you all to this series of Future Plymouth 2030 events. This is, I believe, webinar number 5 on technology and innovation, and I think the next one will be on the circular economy. So welcome, and welcome. Thanks for sticking around at this time in the evening. So who are we? Well, we're the power electronics team at the University of Plymouth. And my role hasn't actually begun yet. I start in the 1st of February, and I'll be the Power Electronics Research Fellow, RF. I've got an interdisciplinary research background. I did a master's in robotics at Plymouth University, where we've also been developing graphene field effect transistors for sensing applications and synthesizing novel nanomaterials for water filtration. So that's been my background, and my supervisor who will be co-presenting this with me today, Dr. Zaki Ahmed. He's the lead academic for this low carbon Devon project in power electronics, and we come under the umbrella of the Sustainable Earth Institute at the University of Plymouth. And this is a collaborative space. This is the green wall you can see in our building. We're an open collaborative space. We've got sort of building management systems up and running. So we're kind of like a living lab on campus to try and roll out all of these aspects of decarbonisation in the real world. And we'll be here as the Low Carbon Devon project will be here to support Devon businesses and enterprises to shift to this low carbon economy. And in particular, our team will be supporting businesses in terms of innovation of the power electronics in that sector. So that'll be our role or goal for the next couple of years. So look forward to engaging with everybody. So today, a little overview of what we're going to talk about will be Zaki. I'll be handing over to him in a minute, and he'll be talking to you a little bit about his product development and the power efficiency work that he's been doing in developing innovative integrated electronics. And then I shall move on to a little bit about my own personal interests and applications of these innovative electronics in terms of battery technology, and what we've seen that is coming on board in terms of fast charging, and I have a particular interest in low carbon transport, which Peter has said is going to be critical as transport is a large emitter of CO2. So that's the order of the day, and yeah, so at this point I shall hand over to Zaki, and he will talk to you a little bit about his current research. Thank you, Zaki.
Thank you. Thanks very much, Jonny. I thought I'd briefly just go through some of the work that we've been doing at the university, as well as how we can actually support local businesses. So with low carbon technologies, there's a lot of electrical conversion. There is the charging aspect, which are AC to DC converters. So this is when you plug your electric vehicle in order to charge it. That converts the energy from the grid into the battery. And from most renewable sources, you have energy generated as DC, which then needs to be pushed back into the grid using inverters. And in both of these conversion processes, you do end up with dissipating some energy into the system as heat, and trying to reduce these losses, trying to understand what the limitations are. That predominantly is the focus of the research that we do. So as an example, I thought one of the elements that we could provide, which you could all hopefully relate to, is looking at things like LED drivers. So if you go searching for LED drivers for high power LEDs, what you normally get is the efficiency rating of the LED, which will be A++ or even A+++. But you don't really get an efficiency rating for the driver that actually enables the LED to work. And if you start digging into the details of the driver, you can come across a lot of very different claims, depending on how the experiments were set up in order to measure the efficiencies. And that's where we can probably help. We have access to very precise power analyzers, so we can look at things like the average efficiencies, and we can also look at things like when you switch things on, the inrush currents and the inrush problems that come about from turning things on. Oops, I think we've lost you, Jonny. There we go. So I think we just need the previous slide, please, Jonny. Thank you. So we have access to very precise equipment that we could use to look at not only the typical behavior of these AC to DC and DC to AC converters, but we can also extend that into looking at things like motors as well, at the mechanical efficiencies. In the previous slides, in the previous presentation, you probably saw that a lot of renewable energy needs to come from mechanical means, from wind power, not just solar power. So mechanical efficiency is part of the optimization problem, and that's where we can help benchmark against different products. Let me go to the other slide, please. Okay, so the simultaneous benchmarking of different products is something that we can support local businesses with. We're very interested in terms of our research at looking at grid connectivity, the flow of power from local storage into the grid, and that involves us looking at things like new and upcoming batteries, as well as new and upcoming power devices. And I think Jonny will talk a little bit more about some of these devices in the subsequent slides. So one of the latest toys that we have in power electronics to play with is a new type of switch called the gallium nitride field effect transistor, which is really exciting for me, but it might not interest most of you. But it is a very, very crucial part of the entire mix of electronics that we need in order to provide efficient power conversion. They're extremely reliable, and during the lockdown period, so in June last year, some of the largest semiconductor manufacturers started purchasing foundries in order to roll out these devices. And just last week, on the 7th of January, ST Microelectronics, who are based in Singapore, so that's Singapore Technologies, they released a new device which is quite cost competitive, and it has a lot of energy efficiency improvements over typical devices. So this is one space that we see as a region of expansion within this field, because we can get cheaper, smaller, and more reliable devices going into the future. And it's very hard to have something that is cheaper, it's smaller, and it is more reliable. Those are three very difficult elements to have. We go to the next slide, Jonny. So the other elements that we can support you with is looking at taking innovative circuit designs into commercialization. At the moment, I'm part of a Plymouth University spin-out company where some of the patents that we had applied for are being taken into commercialization in the area of photovoltaic inverters. So once you've had some experience in this area, certainly from the academic side, it could provide a very useful test bed for others within the community. I think I will probably pass on to Jonny at this point.
Yeah, okay, thanks Zaki, and thanks everyone. So that, you know, we've got a very niche area here of looking at how power electronics can actually help us achieve net zero carbon. And as we looked at a couple of slides ago, these wonderful new GaN FET, which are basically they're the kind of, you know, they're the new MOSFET, and the MOSFET is an integrated electrical component that is everywhere. It's all over the world, and in fact we have a Miles, if you're there, we have a little question here on how many MOSFETs do you think are in a 256 gigabyte micro SD card? Please have a quick go there, and we'll reveal that at the end of the presentation. So what's interesting is that so we have these tiny devices. They're in everything: laptops, electric bikes. They control motors, and they're effectively sort of, you know, electronic switches. And you know, so in terms of this increase in renewable energy production, as Peter and Zaki have alluded to, you know, how are we going to store this electricity? How are we going to manage it? How are we going to comply with DNO as we add on smaller bits of solar here and wind here? And it makes for this, you know, this grid, which is seemingly fragile. We've issued four notices of potential unable to keep up with supply of power this year. So, and we have the issues of peak and off-peak demand with renewable energy. So we're looking to sort of, you know, fill these gaps, but also if there's an evolution in electronic components that are ubiquitous and which our future is going to rely on them, then, you know, we're going to be able to save carbon in that sense. So and this is a little sort of graph here, and as you can see that we are, you know, we are at 5%. We've overtaken nuclear here since 2019. I think it's a better year to take our energy production from, missing out last year. And as you see, natural gas and coal are still up there. So how is that kind of reflected in the UK specifically? And you can see in this, you know, we see that massive squeeze on coal, which is great. You know, coal is, I think we even had a couple of months without coal in June 2020. So, you know, and you can see the biggest shift over the last 50 years is that big squeeze on coal over to gas. Now, if this, you know, if new boilers are being sort of hydrogen ready, you know, and we're going to start to maybe put hydrogen into some of the gas supplies, then imagine if that shift was completely to hydrogen. You know, it would be a wonderful thing. But I suppose most importantly, you can see nuclear is pretty constant, but wind is really, really growing, and solar as well. So we've got a lot of this intermittent energy coming into the grid, and, you know, again, these integrated electronics are going to have to manage that energy and transfer it into the kind of energy we need efficiently, which is where we're talking about a lot of these conversion devices and MOSFETs and GFETs and things like this. So but also buffering the system somehow. And we talk a lot, you know, about battery technology, and there's some interesting and new research, you know, coming out from Cambridge University and spin out companies again that have created this lovely 3 amp hour multi-layer pouch, which is, you know, can be now charged in sort of 6 minutes, so up to 80% of its capacity. So this is, you know, this is also really useful purely because I think it can dynamically absorb those intermittent sources of energy that are coming from wind, that are coming from solar, and they can, we can store them at the production rates. So we're not having to limit things in that way. So, this sort of battery technology coming online is going to be really, really, good for us all to manage this renewable energy that we're going to need. And they've enabled this by changing their anodes, these niobium oxide anode materials, and they're about 35%. They have a higher energy density of about 35% compared to an equivalent pouch. So, this is good news. But do we buffer? As Peter said, are we going to be buffering with batteries? Are we going to be buffering with hydrogen? Are we going to be creating green hydrogen from renewable sources through some form of electrolysis and then storing that? And potentially I can see where this, the EV market is kind of, up and running to some degree, but also the green hydrogen will probably come into where we need it in terms of freight and rail and things like this. So I don't think we need all the help we can get. So these complementary technologies are all going to come in, and even the hydrogen trains have resistive braking, which goes back into batteries. So they have batteries on board. There's battery technology and hydrogen on board, and so it's not a race. It's about using all the tools that we can possibly use. And as I said, EVs, we've had this lovely evolution from our early laptop cells, these 18650s, which are 18 millimeters in diameter and 65 millimeters tall. That's where the numbers come from. And again, that moved from our laptops, it went into those early Tesla cars. What a great idea. And then they moved on to slightly larger cells, improve energy density. And then they're going up for this 480 cell with this incredible tabless design, which I'll go back to. That's the gold picture on the left there. This is all of the anode compressed together at one end of the battery to improve the efficiency of the electrons getting out to where they need to be. So most car producers actually use the large pouch due to this kind of current capability that you can get from a large pouch, but it's at the trade-off to energy density. So we still, the 4680 cells by Tesla are still this jelly roll circular battery cell we're all familiar with. Most EVs are using the large pouch, which is interesting. So, but in terms of transport, I suppose, and range anxiety and all that sort of thing, there's a couple of Teslas I saw in Plymouth. This was when you could get out and about. But we're getting large. We don't need to worry about how far these batteries are going to take us anymore. That's definitely under control, although there's always a bit less than you actually think. But I also noted at the end of mid 2020 that Honda announced they're no longer selling the diesel engine to the British market. So there is a phase out of diesel, and they only do petrol and petrol hybrids at the moment. So, but this is I suppose where, if we're generating renewable energy and we're going to put it into transport, we need to do that. Transport is a huge emitter of CO2, and we've had some local projects which have been very interesting in Plymouth. We've got the Kreml ferry there, which was a kind of collaboration between the Impact Lab, which is at the University of Plymouth as well, and Timbridge Propellers and EV Parts. And on the back of that, I think Plymouth City Council are set to install 22 kilowatt chargers on the Port Barbican landing stage. So that's a really good thing. We can think about maritime electrification, and we also, there's a young man there, not too dissimilar to myself, who I think it was maybe 2 or 3 years ago now, I got a load of old laptop cells and thought, well, if this Tesla guy can do it, well, I didn't say that, but I found a very nice, neat Lego-y kind of kit that you could put the laptop cells together, put on a battery management system, and voila, you've got yourself a lithium-ion battery. And I was using that to cycle in from where I live in South Brent to Plymouth to go to the university and go to work. So, and there's a massive growth in that, in terms of people just using electric bikes for mobility. So, I think that's where Plymouth should go. It should evolve in that way. And that will probably include something along the lines of, you know, sort of personal light electric vehicles, which I think, you know, people are slightly concerned about. But these electric scooters zooming around the city, there's 50 trials at the moment around. And I think I saw on the news today that I think was it maybe Bristol that were kind of, you know, they approved of them, or the police approved of them at least, and said there wasn't some sort of carnage of metal and things like that. So that's a good thing. You're also able to now get plug-in motorcycle grants, you know, and maybe get up to sort of 1,500, there's an asterisk there, for £1,500 off a brand new electric moped or motorcycle. And the Office for Low Emissions, they also are giving you some money towards cars, maybe up to 3,000, and a van as well, which is up to 8,000, you know, subject to terms and conditions and all that sort of thing. So will we be shifting to, you know, cities being electric only zones? I hope so. I think that's good for the air quality. But, you know, will we also need to then take this battery storage and take this battery technology and bring it to our homes and keep it local? So charge all of our electrical mobility devices from our homes, from our power walls, so we can buffer this system, because the grid and the way things are at the moment, without a lot of investment into changing transformers and you know, some of these transformers across Devon are you know, maybe 50, 60 years old, and so, you know, and they're expensive things. So we might be localizing our electricity supply and keeping it to ourselves, and charging our stuffs respectively. So, you know, I hope that's the direction that Plymouth City goes in. It'll be well, it's already a wonderful city, but my goodness, you know, imagine an electric city in Plymouth. That'd be great. So, you know, we're part of this low carbon Devon project, and if you're really interested in getting in touch and taking part in some sort of innovative collaboration with the university, we've got some fully funded internships, and also we're here to work with companies to help develop innovative electrical devices. So please, you know, get in touch there on the email, and we'd love to hear from you. And I think that's all from us. Now, anything more from you, Zaki? How's that?
No, I think that was very good. Well done.
Okay, all right. Well, thanks, folks, and I hope you filled out the poll, because that's quite an interesting one. Thanks, Miles.
Thank you, guys.
Thank you.
Just results of that poll.
Yeah.
So you should see it now. So most of them, 256 million.
Yes,
that's the right answer.
No, it's not the right answer, because you know, everyone loves a 256 or a 128, and they're like, oh, it must be something to do with bits and bytes. But no, it's actually a trillion, which is a million. And, you know, my point was really, you know, these MOSFET devices that we talked about briefly is that they since the 1960s, we have manufactured 13 sextillion, which is 13 times 10 to the 22 zeros of these MOSFETs since the 1960s up until 2018. And if all of those are replaced with GaN FETs, which Zaki was alluding to, and they are 30% more efficient, then that's a lot of carbon that we're going to save. So that's my kind of my point of my poll, really. But thanks very much, everybody.
Wow. Thanks, guys. Well done to the four of you who got that right. Thanks very much, guys. It's really interesting. Again, just so you all know, this webinar is recorded. So if you want to look back to Peter's and Zaki's and Jonathan's presentation and slides, the recording should go live by tomorrow. So you can look back and have a look at those again. Finally, we have Alistair Macpherson from Plymouth Energy Community. He's going to talk about the rationale for community-owned energy infrastructure solutions. So over to you, Alistair.
Can you hear me? See me?
Yes.
Brilliant. Okay. Thank you, Miles, and thank you to Southwest Reba for inviting me here this evening. It's a great pleasure. So my name is Alistair Macpherson. I'm the Chief Executive for Plymouth Energy Community. We're a community energy organisation, and so I'm going to talk to you a little bit about the innovation in community energy and why we need those kind of solutions as part of a transition to a net zero Plymouth by 2030. I'm going to share my screen with you. I do hope. So hopefully you're all seeing that, and someone will tell me if you're not. So PEC. So yeah, we are a charity and a family of social enterprises focused on the energy transition for Plymouth, surprisingly enough. And yeah.
Alistair, I think you're sharing the wrong screen.
Okay.
Sorry, it's got your calendar.
No, that's fascinating. Let me try that again there.
Yeah. Busy man.
Let me zoom back up.
I'll stop sharing your screen, Alistair, and we'll try again.
Zoom's just stop sharing. Excuse me. Really should have got this sus by now, shouldn't we? So share screen. If you just talk amongst yourself, that'd be perfect.
Whilst Alistair's doing that, don't forget to subscribe for our next webinar on the 27th of January. It's the circular economy. So it's www.futureplymouth2030.co.uk. Brilliant, Alistair. We can see that now.
Perfect. So as I was saying, yeah, I'm the Chief Executive for Plymouth Energy Community. We are a charity and a family of social enterprise focused on the energy transition for Plymouth. And I wanted to talk to you a little bit about what innovation do we need? And when people talk about innovation, they often immediately think about the kind of widgets and gadgets that colleagues have just been talking about now. But and we undoubtedly need that. But actually, if you look at the work that the Committee on Climate Change are doing and the reports that they show that Kydd mentioned earlier, it's very clear that actually we have the technological answers to many of the problems we have to get us a long way towards net zero. What we need to do is implement them in a different way. And community energy is a different way of implementing some of those energy-based solutions. So, yeah, with PEC, or Plymouth Energy Community, so it is about giving people and the communities the power to fundamentally take control of their energy futures and Plymouth energy futures, and to utilise the sort of collective power of the community in a way that can engage in different ways. And we're part of a movement that's kind of got roots across I guess Europe, but this slide refers to the work of Community Energy England. But there is a kind of sense that since the liberalisation of the energy markets kind of pushed through in the sort of 80s, we've been in a situation where energy has been supplied to us either by large corporate entities, sort of retail energy, and a small number of them, and most of us don't like them very much. There's 4 or 5 of those that control sort of 80 to 90% of the supply to most domestic houses. And equally, we've got this kind of an energy infrastructure that's sort of owned by large sort of corporate monopolies. And that means that effectively many of the sort of problems associated with the energy transition are very remote to us. We haven't had anything to do with them. We've kind of just been press the button and we get it. Now, that can't continue. Fundamentally, we need to shift our relationship with energy, and people need to sort of understand and engage with energy in a different way. And you know, if we're going to move to net zero by 2030, 2050, whichever date you pick on, we need to effectively give people greater control and greater ownership of the potential for transition and change within their place. We need to normalise what are at the moment quite kind of radically and out there kind of ways of generating and demanding energy. So we need more people in communities to be able to look to the neighbours and say, yeah, they do that, I do that. And that might be an electric car. It might be around, you know, the way they kind of consume energy in their homes. It might be how they engage in activities to support energy generation locally. And it is about giving people a voice in that is fair and equitable. Part of the rationale that we have in PEC is driven by the fact that there are significant number of households in Plymouth that still struggle on a daily basis with decisions about whether to heat or to whether to eat. Now, fuel poverty is a substantial problem in Plymouth, and we kind of want to kind of mobilise a sort of just transition where that energy issue is supported and kind of nurtured with solutions are brought forward that come forward that deal with that problem alongside the climate crisis. And we see that as being fundamentally interlinked with the need to increase ownership and influence over those kind of energy solutions. And so that we can build a kind of community confidence, you know, so not just in the technical specialists, but in everybody, you know, the people like us, the neighbours being able to go to, because yeah, I did that, and we can build that chain and a kind of critical movement and critical mass of belief that, you know, this transition is possible. So that's kind of our mission. So that, I'm going to switch to that poll now. I was going to put up, but just be interested to see how many people, or the view of the audience are in terms of how many households in Plymouth are currently in fuel poverty. So if you get those results, pinging back to us, give us a live feed. This is as much engagement with the audience as we get.
Just a few more to collect.
Yeah, all right. For those, so fuel poverty is in a scenario effectively where people can't afford to power their home, they can't afford to heat their home. It comes as a result of two elements, effectively one, low household income, and two, really poorly built homes. So built homes that are leaking energy, so they're very expensive to heat. And it is a very significant problem in Plymouth. It is also very encouraging to see that people have got an awareness of that problem. Maybe they've heard me speak before, but yeah, 15,000 is the number of households in Plymouth currently living in fuel poverty. That's higher, significantly higher, 2 to 3% higher than the national average. But we, as a nation, are, you know, the bad boys of Europe in this space. You know, our homes are more leaky. You know, our poverty problem is significantly great, and our kind of support infrastructure for those households struggling in that position is worse than many other kind of European nations. So, community energy in Plymouth, you know, we've been focused about that. You know, how do we kind of utilise the transition, make it just, and help us tackle that kind of problem. And we've done pretty well. So we've established since 2012 a successful organisation that is operating in two spheres. We're generating community wealth, we're generating community assets that are owned by local people, managed by local people, that are generating substantial amounts of renewable energy for the city. And we're providing advice. You know, we are a trusted, impartial, not-for-profit that can advise homes and businesses about the kind of investments they can make for the future. So we operate in both those spheres. We've got the ability to bring forward projects, both renewable ones, and we're also bringing forward a new build housing project, but equally to provide advice to those particularly kind of low-income households, but equally in the able-to-pay space, people that are doing retrofits on their property and they want to extend further. So our community energy solution has kind of developed over the course of the last, last 6 years into those kind of 2 areas of operation. Yeah, we're a people-based organisation. We employ about 15 full-time equivalents. We turn over about 1.5 million. We've got investors. We've got 520 different investors. I'll talk about a little bit more in a minute. That we've raised 2.4 million to deploy into projects, renewable energy projects across the city. And yeah, we've got a suite of organisations supported by 18 kind of voluntary non-exec directors that are kind of supporting the charitable and kind of various different kind of more commercial, socially entrepreneurial bits of what we do under the banner of PEC. So we are a people-based organisation, and through the kind of structures that we have for those organisations, we're giving people the chance to own and kind of have a say in how those organisations come forward. And so they're kind of democratic accountability of what we do within a community energy organisation is really important to us, and so we trade on that. And I might be the chief exec, but I'm not in control. That is all the members on the board, or many of the members of the board, the trustees, are elected from our membership, and membership is open and open to all. And if you come on as an investor, you invest £100,000 in our organisation, you get the same rights and responsibilities as somebody who comes in at £1. So there's some kind of equity within what we're trying to do here. So we're operating in a range of spheres. We are advising, we're talking about retrofit at scale and in domestic properties. We're working in new build and zero carbon housing space. But I just wanted to talk as an example about what we've done in terms of driving innovation within investment in community energy. And since 2014, we've raised 2.4 million to invest in community shares to build out community-owned solar farms and solar roofs across the city. That's generating about 6,000 megawatt hours of green power per year, and we're doing that with money that's come from local people that have invested in that entity. So they come in through a mechanism called community shares. We've run 3 community share offers. First one to build out solar roofs on. We did 22 schools in the first scheme in 2014. In 2015, we then did another raise, and we raised just about £800,000 in the second scheme, and we built out another about I think 12 at that time. We did a load of secondary schools, and we did the biggest solar roof in Plymouth at the time. And then in 2015-16, we built out the largest solar farm that we've got in the city, and that's out on an old brownfield site in Ernestsettle. And we've utilised a mechanism called community shares to do that, and that allows us to raise money from local investors and investors from our community of our community of purpose, who come in on a kind of one member one vote and invest between £50 and £100,000 in our entity, and then we pay them back 6% per year, that pays for the capital, and provides an opportunity for people to own and get involved. So these are kind of some snapshots from the family album. So from this is Mayflower School, where we've got an installation on the school roof in Ham. We've got our smallest installation on the Shekinah Mission down in Bar Street, and our largest installation, which is on Science Park and on the Science Park and the Life Centre in Central Park. And then our field scale ground mounted installation that we completed in 2016, that's a 4.1 megawatt installation. And collectively, we now, as a small community energy startup, now own 20% of the renewable energy generation capacity in the city. And when you consider that kind of totals of that 100% include things like the energy from waste plant and energy generated from the Cheltenham Meadow kind of methane gas extraction, we are a significant player in the provider of energy infrastructure for the city. So something we're very proud of, and if you add that in.
Alistair, sorry, can I interrupt you a sec? Your slides don't seem to be coming through. It's just on your logo sheet, the logo screen.
Okay.
Sorry, we've only just noticed.
Sorry, Alistair, we didn't want to interrupt you there.
We thought you were just talking to us, but
well, I'm not sure.
Do you want to skip forward to wherever you are?
Well, I am on mine. They're moving forward on mine, they're not on yours.
No, it's just got your logo on the screen.
So screen share is paused.
Oh well, we can share the slides.
Oh, there we go.
There you go. Yeah.
Okay.
We'll do a download of the slides on the website as well at the end as well, Alistair, if anyone's missed any of the other slides.
Sorry to interrupt you.
Okay, well, quick, so in terms of the photos, there you go. Yeah, so solar roof on Mayflower School. This is our smallest one in Shekinah Mission. This is the one on the Life Centre, which was until recently the biggest installation in the city on a rooftop. And then this is our ground-mounted scheme that we completed in 2016. So in terms of an impact, as I said, we do own over 20% of the renewable energy sort of generation capacity within the city. That generates a significant amount of clean green power that feeds into the local grid, and through that we're generating very significant savings to local schools. We've got our advice team working on a daily basis, kind of working with households and supporting them with a range of fuel poverty related and then domestic retrofit sort of solutions, and all that generates into significant savings to the local economy, be them to local schools and community businesses, or to the household kind of budgets that we're kind of either saving money from their short-term bills or from long-term bills in terms of improving the domestic efficiency of those properties. So that is all good for the local economy. That also all feeds into that story about like kind of normalizing this, and this is about a community energy solution. It's about local people taking control of that, and that's what's happened here in Plymouth. We are a leader in that respect. There are a few places around the country that have really kind of been very successful as us in terms of mobilizing this kind of community approach, and we fundamentally believe that's going to be absolutely the continuation expansion of that approach is going to be key to us being able to move this transition to 2030. Again, if you go back to the Committee on Climate Change's work in this space, they clearly say that like 65% of the policy interventions that are required to get zero carbon require substantive behaviour change. So these are not just kind of policy levers that can be pulled from a central level, in a central way, in the same way maybe turning coal off has been able to, or there may be sort of effective expansion of the electric vehicle market. Fundamentally, people and businesses are going to have to change the way things they do. Fundamental behaviours will need to change, and that is a process that will be eased and made faster, quicker and easier if local people can look to local examples of things that happen and understand those examples, or even being part of that transition, and equally feel that maybe some of the benefits of that transition is coming back in terms of supporting activity in their local patch. So that's community energy in a nutshell. For me, we're now moving on in terms of thinking about how we can have community approaches in the building of new build homes, and we're trialling a 38 home net zero housing development in Kingston. We're working with organisations to take our community energy measures to Glasgow at COP26, and we've just completed a share of a crowdfunder in November to fund that, a very successful one. We raised £50,000 in just over 4 weeks, and we're continuing to look for further sponsors and supporters of work to get us to Glasgow in November. So I think that's a little snapshot into the innovation associated with community energy. It's not a technological innovation, it is a social and kind of mobilisation innovation. So thank you for your time, and if anybody wants to get in touch, I'm sure my details will be shared later. Thank you.
Thank you very much, Alistair. That was pretty good. I'm really sorry about the technical problems we've had in that one. What we'll do, we'll do a download of your slides just so we can make sure that everyone sees them. Thank you very much, Alistair. Now move on to a Q&A session. If anyone would like to ask a question direct to the panel, please raise your hand now or submit questions through the chat. Whilst you're doing that, I would just like to say a big thank you to our sponsors, Plymouth City Council, REBA, the Low Carbon Devon Project, the University of Plymouth, Building Plymouth, the European Union, Constructing Excellence, Her Majesty's Government, and Strides for Growing. Thanks so much for your continued support of our programme. And also thank you to all our partners. There's so many to mention, but they're all on our website and our slide at the end. Thank you for being part of this. So we have a few questions coming on the chat. So this one's from Casper. So how can smaller engineering consultants and startups get involved? That's probably to the panel. Anyone like to answer that question?
Shall I start off, Peter Kydd here? I think the key is really to be aware of what changes are coming in, and to start preparing your workforce to really take advantage of those opportunities. So I think there are opportunities, I think, for consultants of all sizes, and there are lots of opportunities for startups who are probably more prepared to take risk than engineering consultants. But I think the key to both is to understand what's happening in the space, understanding where there are challenges in deriving solutions. Work with universities, I think, is an absolutely key element here, because I think they can sometimes see into the future much better than the rest of us. And I think sort of taking a collaborative approach into the future opportunities means that everyone can get involved.
Thanks, Peter. Would anyone else like to add to that? Cool, brilliant. So please raise your hand. Don't be shy. If you've got a burning question you'd like to ask any of our panelists, we've had some really interesting questions come through. I thought this one was quite interesting. I know you've answered it, Peter, but it'd be good just to go for this one again. Which alternatives to petroleum industry exist today and are being developed in production of hydrogen?
So my answer was really looking at it from, and I assumed that the questioner was sort of saying, if you're working in the petroleum industry, where does the petroleum industry go if suddenly fossil fuels aren't going to be in demand, and so on. So I think it comes back down to what is the core purpose of the industry, and the petroleum industry's core purpose, in my view, it isn't just to get hydrocarbon products out of the ground. It is actually to provide energy, so that we can all move around. So I think what the petroleum industry has to do is to ask itself, right, if fossil fuels aren't the solution, what can we move into that will be part of the solution? And I mean, various petroleum companies have tried this. BP, for example, used to have a phrase "beyond petroleum," which sort of lasted through one chief executive. I don't think it lasted through the next, but I think their later leadership is starting to embrace that again, and I think that will be that will be the future. I think all of these industries need to define themselves as energy providers and look at how they produce provide new forms of energy.
Thanks, Peter. Matthew, if you'd like to ask your question.
Yeah, it's a question for Peter, really. Thank you. We've seen it mentioned in the news a few times recently, the growth of micronuclear, these micronuclear power plants, sort of early design stages concept. Just wonder what Peter's thoughts are as to how realistic they are, and where would they fit in within the sort of grid in terms of complementing other, renewables, and meeting peak demand at certain times of day. I'd be interested what his thoughts are on it, as how viable is it really moving forward?
Yeah, well, there are a few players who've got involved in this. I think Rolls-Royce being one. I mean, when it was first mooted, which was about 10 years ago now, I mean, none of these, interestingly enough, none of these sort of ideas are particularly new. They have been around for some time. I mean, I think that the questions that were immediately asked were, in relation to security, because if you've got a large number of small nuclear reactors, security becomes a bit of a bigger risk. I think the original concept was, can you take the sort of nuclear power plants that a submarine might have, a nuclear submarine might have, and deploy those around to provide more local energy for municipalities and so on. I have to say, I'm probably not, if I was a betting man, which I'm not, I probably wouldn't. I don't think there would be I don't think there will be a big future in modular nuclear, simply because of the risks associated with it. I don't see it being. I think it is quite a risky technical proposition to roll out in an uncontrolled, or not. I suggest it would be an uncontrolled, but in a large rollout. I think nuclear, more than anything, probably needs to be focused on large plants. Apologies to the PM's 10-point plan.
Thank you, Peter.
Okay. And just to add, do you see the right level of investment going into the national grid that will allow it to keep up with the innovations in energy generation? We've got wind farms, we've got solar, we're spreading our energy generation facilities across the country. There's a lot of money going into these new technologies and these new processes, yet is the grid itself falling behind?
Yeah, the grid is, and I think it recognises that it is, and it needs to be more flexible. There's certainly National Grid have produced some ideas about how they can make better use of or send some of their responsibilities to the to embedded generation on the distribution network, rather than necessarily have everything focused on a national grid which just sends out energy. So I think there is a more flexible system at the DNO level that will emerge and that will help. I think National Grid's problems are probably foremost in terms of security of supply, and so a lot of the embedded generation in DNOs is going to actually create some challenges for National Grid in terms of how they ensure security of supply, and I think that's where their focus will be. And I think that's whether they've got enough investment to do that. Well, National Grid is a privatized entity, and its business model relies on it finding answers to these difficult challenges. So I think you will find that there will be quite a lot of work to achieve that. But I think the easy bit, so to speak, is to encourage more community and local generation and consumption, and to allow the National Grid network to really be for the more strategic shifts of energy from one part of the country through to another. Yeah, I think that's probably enough from me. I seem to be speaking rather more than anyone else, so please, anyone else, do join in.
Thanks for your question, Matthew. Thanks for your answer, Peter. This might be a question for other people. It might be for you again, Peter. Paul Reed asks, what are people's thoughts on nuclear fusion as a future clean energy source?
I can give a very simple one-liner. Nuclear fusion was 40 years away when I started my career, and it's still 40 years away.
I have a very similar opinion. It'll be a great idea, but I think it's still too far away, and I don't think we can predict when we'll actually have a safe, stable nuclear reactor or a fusion reactor. We have one up in the sky, so we can try and use that as much as we can.
Yeah, I mean, I'd kind of add to that and just come back to the point I made in my talk, is that, you know, we have the solutions. You know, we don't need to look for that new technology. We have the technology that we need. We just need to deploy it faster and at scale. That's the issue, and we need to embrace that. We need the policy kind of alignment that Peter alluded to at the beginning. You know, that's what will start to unlock some of this stuff. And to pick up on the previous question around capacity, you know, as somebody running an organisation trying to increase local generation, we are constrained very significantly by the local grid. We cannot roll out more renewable energy at this kind of scale as required, fundamentally because there isn't enough copper in the ground to distribute it. So, you know, the DNOs are in a challenged position. You know, they are, yeah. There isn't enough investment there to effectively, to get that copper in the ground, and so they're constantly trying to balance demand and supply without enough investment. So there is need for more there, and I think, yeah, the DNO, WPD, and others are in a process of transition, but you know, they're still kind of a long way away from how it's run, you know, effectively on the continent, where you do have kind of, I guess, public entities that see that kind of grid network as public good rather than, you know, an infrastructure to be supplied by a private company, because that's what it is. You know, we can't make that transition without a really smart, well-managed, power distribution network. And you know, whilst the DNO is in a process of transition at the moment, that transition isn't moving quick enough to drive, you know, 2030 or even I'd say 2050 kind of solutions. It is a significant on the growth and generation at the moment.
Thanks, Alistair. We have a question from Emma. Are there other companies other than Tesla who are developing a battery that can cope with the demands of a three-phase supply? When do you think these will be coming to market? I've certainly heard of there's a big push in China actually now, isn't there? There's NIO, and there's Xpeng and Li Auto, those kind of car companies. Have you guys heard of those?
Certainly, NIO are kind of touted to be the sort of Tesla of Asia.
Yeah.
So they and you know, I would not be surprised if they shoot along and have developed something just as good or even better than at the rate that they work. So, but no, I haven't, Emma. No, I don't. I'm not quite sure what you mean in terms of three-phase, you know, three-phase supply of. I mean, the DC batteries, you know, all the motors are three-phase generally. So you've got a conversion inside the electric car from DC to three-phase, which is, there's losses in that. I think there's about 17 or 18% loss overall from just taking the energy out of the battery and putting it into the motor again. So yeah, it's from my perspective, and maybe Zaki's, it's all about efficiencies in transformation. And yeah,
it's going back to Peter's point of actually how do we charge these cars, I suppose. I think one of the things that I saw that NIO was doing is they were doing these battery swap stations, a bit like a petrol station at the moment. You drive into these, it swaps the battery, I think 15 minutes or so, and then you drive on again, which I think is genius. Because again, you know, rather than dragging a cable along the road like you had in some of your photos, Peter, you know, all these things need to be thought about. Emma actually said, she just replied, she was meant for houses, not cars.
I think there are larger batteries, and the likes of LG provide larger sort of Powerwall batteries, but they're based on very similar technologies to what Tesla use, or the Tesla Powerwall. I think a lot of companies are looking to getting into this space, but just using existing battery technologies. But there is a possibility with better batteries coming on board that, you know, the energy densities will be better, they'll be a bit more reliable and a lot less likely to catch fire, because if a lithium-ion battery catches fire, it's quite frightening just how much water you need to take to put it out. So I'll wait for the more safer batteries, like the sulfide-based batteries, to come out rather than the existing ones.
And it's quite interesting, I think, on a battery perspective. If you've got a battery that charges quickly, you need to be able to supply that energy to the charge station, and therefore you need again, what Alistair was saying, but you need the infrastructure in place to then, you know, bring in these higher charge rates, and that's so again, it kind of, if the pinch point is the grid, then you know, I don't know. I think there is something to be said for that.
Yeah, that's the point. Is the grid going to be able to cope with these charging stations that we desperately need to build? Thank you for answering those questions. Matt, do you have another one?
Yeah, it's just following on from that discussion. It's quite interesting because you could argue, you know, the issue about charging stations. You know, is this an opportunity for small business enterprises? You know, these charging stations. You know, in Vietnam, you know, my wife and I had an electric scooter, and you have cafes now around Saigon, Ho Chi Minh, where you can go and have a coffee, and they literally do. They'll swap out. You can charge your battery. They'll swap them over, and this is being driven by young entrepreneurs on a small micro scale. But it's achieving traction within society. So, you know, it'd be interesting to see how we can look at what other countries are doing and their approaches. And I suppose really it was a question as to what role is there for community enterprise schemes to facilitate some of these new, you know, the adoption of some of these new technologies. If government and legislation is not able to move quick enough, you know, is there actually an opportunity? Alistair, really, I suppose this is aimed at you, you know, for community-led initiative to fill the gap.
Yeah.
I think there are, yeah. And there are a few community energy organisations, and my colleagues that run Brighton Energy Co-op are looking at community energy, power EV charging, one form or another. And there's a few kind of rural projects happening in sort of around the borders in Wales as well. The issue again is that kind of access to the grid and that kind of grid infrastructure. The kind of revenues from charging are actually quite small at the moment, and so being able to get and secure the grid connection is the key thing. I think that's where the value is almost. And so, I mean, in a dream world, you know, in terms of the perfect scenario for me here would be, you know, effectively where you had a kind of publicly minded entity of some form that was kind of taking some control over the long-term ownership of those grid connections, and being able to, you know, facilitate smaller enterprises to get access and to be able to trade on them in some form. Otherwise, we may see the same problem that we had with the rapid deployment of wind and solar during the sort of 2009, 2010, 2011, 2012, where there was a kind of race for grid, where effectively there was a kind of holding on by large corporate entities for grid capacity, and then that not being released. That problem has now been resolved. You know, WPD and other DSOs have kind of put stuff in place to stop that happening, but I think, you know, you could apply the same lens on where we are with EV at the moment, and there's a lot of entities going around trying to snaffle up grid because they know there's a need for these power stations. So if you could have some intermediary in the place that was kind of, I guess, had a public overview public benefit overview in some form, and there's a number of different ways you could structure that. And then I think you'd have a greater opportunity for smaller community entities to get involved and to trade in some form in small enterprise. At the moment, it's likely to get kind of, and I think this is the direction travel at the moment, if we get sort of snaffled by the big infrastructure providers.
Thanks, Alistair.
Thanks for that.
Thank you, Matthew, for your question as well. If there's any more questions, please put them in now. Just whilst I remind you of our next webinar, which I know loads of you have signed up for already. If you haven't, please go to our website, futureplymouth2030.co.uk. It's on the circular economy. And we have two great guests for that one. We have Richard Harper from Hawley, who will discuss how this can be applied to the construction industry. And Professor Catherine Willis from the University of Plymouth will explain what this might mean for the city of Plymouth. So please join us for that. It's on the 27th of January, same time at 4 o'clock. I think that's all the questions. So thank you so much to all our guests. Thank you to Peter, thank you to Jonathan, Dr. Zaki and Alistair for joining us. And thank you for you guys for your time. I really hope you've enjoyed it, and we'll look forward to seeing you in the next one. Thank you very much.